about stems from this Florida Coastal Everglades long-term ecological research program. This is a long-term program to understand all the kinds of changes that are happening in South Florida that are interacting in so many different ways with how we manage the Everglades and the ways in which we see the Everglades changing into the future. And so the kinds of things I talk about tonight are really representing breadth of knowledge that comes from all those collaborators in our program and lots of different agencies and entities we've been working with in that program all the way along. And it is fun to be giving this talk tonight in this room where the paperwork was signed to create Everglades National Park, where we have these incredible paintings with by the Florida Tropical Botanical Artists, which is an amazing group, and they've been doing really cool artwork all about the Everglades for some time. And so I'm really excited that y'all are here, and let me give you just a little overview of what I'm going to be talking about. So the Everglades is this environment that a lot of us have been thinking about as, you know, wholly unique. Marjorie Stoneman Douglas, who hung out there and really pioneered what the Everglades is all about decades ago, talked to us about that and wrote about it and said, you know, we need to think about this landscape as something that really is so different and so important that we need to really take care of it. And I want to explore a little bit about those properties and how we might think about them as we see the Everglades changing in different ways with the sorts of influences that it's received over the years. And then a bit about the surprises that the Everglades is constantly presenting us with, which is really a Pandora's box of paradox, and hence the title at the top. And then I'll be talking a little bit about these three different areas: the perplexing periphyton. I'll get into what that's all about, but that's close to home for me. I study the little algae mats of the Everglades. The unassuming consumers, the upside down estuary, and then talk a little bit about whether or not we can manage the system in a way that retains those interesting features that we think about when we think about the Everglades. So we'll start with this concept of uniqueness. There's Marjorie Stoneman Douglas, and I'm sure she hung out in this room quite a bit. And this is her famous quote from The River of Grass, that, you know, we really don't have other places like this on Earth. When you get into the middle of the Everglades, it's really such an incredible expanse and so different from other kinds of wetlands, and nothing anywhere else is like them, is what she said. And certainly when we think about the different kinds of habitats out there, we've got our sawgrass meadows and marshes and the wonderful cypress forests and these expanses, and a lot of what we see here in yellow is the reflective periphyton growing on the surface of the water. Very unusual. And then all of that fresh water flows into our incredible estuaries that drain out to the sea and interact with the sea in really, really interesting ways in Florida Bay and the Gulf of Mexico. And these incredible tall stature mangrove forests that are some of the most productive forests on the planet. We're learning from this research. We've been studying the rate at which these trees remove carbon dioxide from the atmosphere, and they rival our tropical forests in the Amazon, which is really kind of incredible. And you know, looking out onto Florida Bay, these kinds of images that you only conjure up when thinking about South Florida. And of course, all of our species. So we have an array of species that are pretty endemic and only found down here that we care about and are working to protect. When we think about those unique properties of the Everglades, you know, we can think about all the animals and plants, the different ecosystem components, these different unique habitat types, but also the people, right? The human history down here is fabulous, and it's deep and it's rich, and we have this incredible history of Native American occupation and use of the landscape in creative and wonderful ways, and then the Gladesmen in later years who really interacted deeply with the natural landscape. And then today, when we think about the ways in which people interact with the Everglades, it's really a human-dominated landscape, even though when you're out there, it's not the kind of place where you're running into people left and right, unless you're on the main trails. But it's one where we are interacting with it. It supplies our fresh water. It is a place where we go to recreate and to fish, and where we have many dependencies on all the services that are provided. And so that's another, sort of unique history of the evolution of this landscape. So when we think about the ways in which it has been changing with the ways in which we've been interacting with it so heavily in the last several decades, we have to wonder this question: is it still retaining those properties? And so here we have this massive dredging operation that started up in the early part of the 20th century, where the huge canals were dug and things like Tamiami Trail were created out of the spoil. And that, of course, changed the whole entire way that water moves around in the landscape and the ways in which organisms can function there. We also, so if we look at the wonderful imagery that we have today, looking down on the Everglades, here we see our thousands of miles of canals and, of course, the incredible sprawl of urban South Florida. But we can contrast that to this wonderful image that Chris McVoy recreated, if any of you have read his book on the pre-drainage Everglades. This is an image made to look like a satellite image, but to contain all the kinds of habitats, the expansive sawgrass plains, the ridge and slough, these incredibly expansive marl prairies, which have just been so compartmentalized today. And of course bounded by this agricultural area that's delivering nutrients and creating a real difference in the way that water moves and in the quality of that water to the system. And so we've got nutrients moving in from the upper part of the system from all this sugarcane, and I guess sod farming is now one of the biggest industries in the Everglades agricultural area, which actually came as a surprise to me. I always thought it was mainly big sugar and the winter vegetable farming, but there's a lot going on up there that creates this problem of water quality that we've been so worried about for the Everglades over the years, and this encroachment of cattail that we can see from the satellite imagery that has changed the system so much. And of course invasive species, right? So on top of the onslaught of all these kinds of ways in which we've drained the water, we've changed the nutrient status, and we've also allowed things like this to invade. And our team, these are two of our technicians that maintain our LTER sites, and they run into these guys every so often, taking up refuge around our instrumented sites, because those are nice and warm from the battery packs, and they wrap themselves around them and have a little siesta. That would not be me hanging out with them like that. So we've had some researchers thinking about this a bit. Vegan Kitchens have talked about the Everglades turning into something maybe we should be calling the semi-glades. This is actually quite controversial, perhaps an idea that we don't want to embrace deeply in some ways, because it conjures up the notion that perhaps it's not what it once was, and therefore not valued for protection. And so we've been thinking about this a bit at FIU, the kinds of ways in which the system has changed, the ways in which it's remained the same. And whether or not it's unique or existing as the sole example, is it the only thing out there like it? Is it novel, which might be equivalent to this idea of the semi-glades with these kinds of new properties? Has it taken on completely new function where it doesn't resemble what it had before? And another term we can think about is distinctive, recognized for these salient features, and perhaps sort of a global sentinel or representative of this kind of habitat. And so all of that is a bit based on our concepts of expectation. You know, what do we think that Everglades is, and what do we discover about it, and how does that align with those expectations? So I want to move into how does the Everglades surprise us, and talk about each of these different aspects of the system, and think a little bit about whether or not they fit these different kinds of ways of describing systems as different. And so this is this marvelous picture of Pandora. I thought she's really like alive in the Everglades. And every time we go out there, we find something new and something different. And even though there's a huge history of research in the Everglades, we keep learning new things about the system, and there's so much more to discover. And I like this particular image of her because she's got this box with all kinds of nasty things, including things like algae. No, I love her little box of bacteria she's let out. And so the paradoxes I'm going to be talking about, the things that seem different from what you expect, include things about algae. That's the beautiful diatom in that picture. I'll talk a little bit about the little animals that are dependent on that base of the food web, and a little bit about the whole ecosystem, zooming in on our estuaries. So starting out with this perplexing periphyton stuff, and anybody who's been out to the Everglades has seen this big floating mat of algae that forms on the surface of the water and on the plant stems, and is one of the most abundant and notable features of the system. And to understand why we have gobs of algae growing in mats like that in the system, we need to get at a little bit of the history of the system. Its geological history, which is that it's on this limestone that we see all around here, and that limestone really confers a lot of pretty unusual properties to the system, having that calcium carbonate base. And it's not just that it's a big base of limestone, but it's really flat. And so that means that water moves really slowly over it. It's super susceptible to sea level rise. And so we have, you've probably seen this sign if you've driven down the main trail of the Everglades, where you pass rock reef pass all of 3 feet. So the big pinnacle of the Everglades. So this limestone underneath the Everglades really draws, it does a lot of things to the chemistry of the water to start out with. It takes nutrients that feed plant growth and it sucks them out. It's really good at absorbing those. And so the water tends to be really clear, which is great if you're on the lookout for pythons or alligators that might be sneaking up on you. When you look down through the water, you can see those mats of periphyton kind of seeping up off the bottom. And the concentrations of nutrients in that water are really, really, really low, because limestone just doesn't have much nutrients in it to begin with, which is typically from the rock where a lot of nutrients come from in ecosystems. Limestone doesn't have it. It absorbs it, but it doesn't have much of it naturally. And so the water is depleted in the very thing that the plants need to grow, phosphorus. And so the levels are below 10 parts per billion, which is the number that we use to protect the Everglades. It's a level that we know above which causes all kinds of changes. And so what we would expect in a system like this, with hardly any nutrients there for the plants to grow, is very little of any of the stuff we would normally find in a shallow water column, like the little algae. If there's not a lot of nutrients, the stuff we put on our lawns to make our plants grow, we shouldn't see a lot of this. So this is bizarre. When I first started working out there, it was very strange to find gobs of this being supported by very little fuel. And so we started this huge mapping program sponsored by the South Florida Water Management District and our Army Corps of Engineers, who are doing the major reconstruction of the way that water moves around the Everglades through our comprehensive Everglades restoration plan. And they want to know, are these projects working as we implement them? Let's put into place a mapping program to detect that. So we have lots of sites that we're sampling. We've been doing this for 10, 15 years now. And we go out by helicopter, so it's a lot of fun. And you never get tired, even though it's a long day of work, to see the Everglades from that height. And we use traps like that we catch all the little paraphyton in and all the little animals that live within it. And when you look down through these traps, you see some sites have tons of paraphyton like that. And you can see the scale here. We're talking about the amounts of paraphyton in milliliters per square meter. So we're talking like 10 liters. It's a huge, huge amount of paraphyton at the sites that are the bluest here. Some sites have a little less, and as we get up into the northern parts of the system, we have less. And as we collect these kinds of data, we can start understanding the patterning and the reasons why the paraphyton is in some places and not in others.